Hello, this is Lorraine Jamison. I'm really sorry if this recording is really spotty or for the angle. I am currently in the middle of nowhere, Michigan, camping with my family, so we have driven to a library, also in the middle of nowhere, Michigan, so that I could steal their Wi-Fi because there's none at the campsite. Anyways, and this hopefully I will probably get all my work done on time, but if I do not, this is the reason. Anyways, this is quiz number 12. This is Lorraine Jamison, and question number 1 was to find the inverse of a matrix using the augmented matrix in Gaussian Jordan elimination of the matrix A equals 4, 8, negative 3, negative 5. So I know that the inverse of a matrix is equal to 1 over the determinant times the adjugate A. And the determinant is negative 20 minus negative 24, which is equal to 4. The adjugate is negative 5, negative 8, 3, 4, because all you have to do is flip this first diagonal, and then you negate the second diagonal. So that means that the adjugate is 1 over 4 of negative 5, negative 8, 3, 4, and that's equal to negative 5 fourths, negative 2, 3 fourths, and 1. Next is to find the eigenvalues, lambda 1 and lambda 2, and eigenvectors of v1, v2 of A is equal to negative 1 to negative 4, 8. And so in order to do this, you just subtract lambda from these diagonals, and then you solve for lambda, because this is just equal to 0 in order to find that. And you're subtracting the diagonals because you're finding the determinant, because the determinant of this has to equal 0. And so you subtract and you simplify, so you can get lambda minus 6 times lambda minus 1 is equal to 0, and then you have your eigenvalues of 1 and 6. And then after that, you use this, which is A minus the eigenvalue lambda times the identity to get your eigenvectors. So sorry, there's a grasshopper on me. So I have subtracted the first eigenvalue, which is 1 times the identity, to get this matrix, and then in order to solve, you can do row subtraction, so row 2 minus 7 halves row 1, and that equals negative 2, 2. So negative 2x1 plus 2x2 is equal to 0, so x1 is equal to x2, so you can just put an arbitrary value in there because each scalar can also work as an eigenvector. So you have 1, 1 for the first one, and then once again I subtracted this time 6 for the lambda value to get that x2 is equal to 7 halves x1. So that means that, again, arbitrary values, I just put x2 is equal to 1. So x1 is equal to 2 over 7. And so that means that are 1, 1, and 2 over 7, 1. Thank you.